when I was working on it before, but I'll also upload a video. Let's see. Okay, there's a stream there. I'll go back and watch it and see how it is. Um, Sometimes the network kind of makes it really, really bad. Check, check. Okay. Third time's a charm. This is rebooting. This might be the first time that you get a class with me, like even if you have robotics camp, because I'm a different person when I'm dying of poisoning or something. Um, like if you knew me before my gallbladder issues, I was a nice guy, and I feel like I'm a nice guy again. So I apologize if I was a jerk to you. I don't think I was, but I feel back to my old self. Okay, like I was I was building up in bilirubin pretty good. I had like your gallbladder like takes all your bile from your liver, concentrates it, and then it's supposed to be to help you digest, but my gallbladder wasn't really letting stuff out, so I was poisoning myself. And throughout the day, I would just get worse and worse and worse. And I'm pretty strong when it comes to pain. I broke my neck, cracked my back, busted up all this, gimped up, had a lot of issues. And I would take that broken neck over nausea any day. Like I'm a baby when it comes to nausea, and I had like 3 months of that, or near about 4 months of that. And that's rough. You ever felt like you had to throw up, and you were in a group of people and you couldn't? Like so, all you could think about was uh, like not throwing up in front of people. Well, that's how I was every day. So I wasn't able to concentrate. I wasn't able to do anything. So I was definitely not um putting my best foot forward, or I was trying to, but I would prefer to like curl up in the fetal position. um, on the bathroom floor. Like, so this will be the first time y'all actually get to meet Robbie. See, like when I was sick, things like this would bother me because I'd not be able to think well enough to um, get it going. Um, but now it's no thing. Um, like our school has an enterprise network, and what happens is there's a lot of people who would like to do damage to it, not to damage it, but so that they can get money from uh, whoever they're working on. So they'd go in and get a bunch of information and encrypt it and all that. So we have to be real careful about how we do our network. Well, having things jump back and forth through the network isn't the most secure thing, so I have to play by their rules. Let's take that off. And on the live, it's only recorded a minute and a half. Has it stopped? Oh, well, like I'm also recording it on my hard drive, so I'll upload it for them whenever uh whenever I'm done. All right, so what I'm gonna do is restarting air server on here so I can get the network. Bingo. All right. So, uh, hopefully this will go how I hope it goes for Time Eternal. It's real stressful to um, constantly be sick. I hope I never go back to that. It's very hard to you know, do what you're supposed to do when all you can think about is uh, not dying. I know it sounds really, really over dramatic, but it hurts so bad. Like, I mean, just constant like sickness. So um, I I hope I never have to go back to that. And I hope none of y'all have to deal with that either. So this hopefully will be a lot more like uh, now it might be slow, but um, hopefully we can get by as things get quicker. All right, so we learned about series and parallel resistance, right? Okay, so if you have an issue with understanding that if we put things resistance in series, that's going to get more resistive. If we put a 10 ohm resistor and a 10 ohm resistor in series, we get what? 20 ohms, right? It just adds 1 to 1, you know. And if we put them side by side, they're actually going to make it easier for things to get through, right? Okay. So, let's look at voltage drop. Okay, voltage is a potential energy. Okay, it means how much energy do we have to do work. Okay, and as we go through things, as we do work, we lose that potential energy. Right. All right. So up until this point, like we would do things like this, and we'd use a voltage source that, well, let me move this a little bit. Like, we shouldn't have as many technical difficulties once I get this going and not sick. All right. So uh, we had a voltage source. Usually it was a circle that looked more like a circle than mine right there, but we use that as a voltage source. Right. All right. So like for right now, if you draw a lot of lines, especially if you have a lot of things connected to things, okay, um, it can get real confusing. We'll get back on there in a second. Okay. Um, it can get real confusing when there's 50 lines crossing. Okay, so if you have a circuit and you have a lot of things tied to that 12 volts, you might just put 12 volts, right? And then infer, it'll come back, infer that all of those 12 volts are connected together. Okay? It just makes it a lot easier than having 50 wires going to, your 12-volt terminal. Okay? Also, we generally in DC, like we'll throw out a ground symbol which looks like a triangle of 3 lines. Okay? And it will represent, like, in this case, our 0 volts. Okay, so in this case, like those two resistors are going out of the 12 volts and they're coming back into the 0 volts of the source. Okay, everybody cool? This ain't adding too much yet, right? Okay, so now what we need to do is another 100 ohm resistor. All right. What I want to get out of today, it'll come back. Well, let's pray that it comes back. Um, is that uh as that voltage is touching all of those things, right? Like we got 12 volts up here, and what do we have at the bottom? We've got 0 volts, right? That we have what's called a voltage drop. Okay, that there's some amount of voltage, some amount of energy that is lost by going through there, because it makes sense. Once we go all the way through there, we went from 12 volts potential energy to 0 volts potential energy, right? Down at that 0 volts, it has no potential to do anything. Okay, all of that makes logical sense, right? Okay, so how does it do that? Like, where does it go? We talked a little bit about it in the book. I'm learning how to do things again, I guess. Um, so where does it go? Anybody venture? Exactly. Like everybody got that, right? Like, uh, I start off in the morning with a whole bunch of energy. Where did it go? Did it disappear? No, I used it, right? I used it to get through something. A resistor is usually made of um, inert material and something that can conduct. Okay, like a resistor is a conductor. Okay, it just doesn't conduct as well. Okay, so if we mix, let's say, some graphite is pretty easy to get electrons through with some just glass or something, sand. Um, Depending on the proportion of that, can't we change how easy or how hard it is for an electron to get from point A to point B? Yeah. So, uh, there's nothing magical about it, right? Like we make little things that are about the same size as each other, but they exhibit a lot of different characteristics. It could be the same size, but it might be 1 mega ohm. 1 mega is what? 1 million, right? So 1 million ohms. That means that it has very little conductor in there. The proportion of whatever they mix with it. It has very little um, things that can conduct. Okay, and so if that voltage is trying to get through there, it's got to work very, the voltage doesn't get through there. What gets through there? Current, right? But you could think of the voltage as what's pushing the current, right? It's the pressure to push those electrons through. Okay, so we generate heat. Okay, now if it took 400 ohms to go from 12 volts down to 0 volts, right? I'll figure out what's going on here. Um, uh, how much of the voltage drop? What was the total voltage drop? 12 volts, right? Like we went from 12 volts to 0 volts. Okay, it's pretty easy. It's just like stacking beans. Okay. All right. So how many volts did it drop if we were to take a meter and we put it at the very end of like between that 12 volts and the bottom of that first 100 ohm resistor? How many volts would it drop? With just the one little portion of that. Yeah, like since they're all equal, they're all going to drop proportionally. Okay, like it doesn't matter if that was 1 ohm resistor. Like if those were 1 ohm resistors, we would drop 12 volts across four resistors or 4 ohms, right? Because we started at 12 and we ended at 0. As long as they're proportionally the same, they're going to drop proportionally the same. Well, let's say this: they all drop proportionally the same. So if they're all equal, they're all going to drop equal. Did I drop? Yes, ma'am. Well, if we've got 12 divided by 4, so a fourth of it. So three, three, three. Okay. So I dropped 3 volts right here. So what would I measure right here? Like if I went between uh this ground and this point right here, what would I measure between? What? None, right? So that's important to think about. Like if you're measuring across the resistor, that's a lot of times a different measurement than I ask what's the voltage at that point, right? So it dropped 3, but that means that like right there, I've got 9 volts, right? Because we're all using that 0 volts as the reference point that we measure from, right? Cool. What would I measure at this point? 6 volts. Are y'all starting to see some power here? That okay, the power company gives us 240 volts center tap, so we usually use about 120 volts for the most of what we're doing. All right, now AC power is different, and y'all learn that. But how many different voltages do you use throughout a day? Like up there, that's 120 volts, and then we've got a 24-volt signal. Your computer,